Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss superposition of two perpendicular simple harmonic motions of different amplitudes and time periods in the ratios 1:2 by graphical method. Let's begin. Here we discuss two simple harmonic motions of different amplitudes, and these are at right angle to each other and having time periods of the ratios 1:2 that are acting on a particle. Let the two vibrations having the phase difference, let be theta between them, and these are represented by the equation x is equal to a cos 2 omega t plus theta, and another equation y is equal to b cos omega t. Here the frequencies are in the ratio of 2:1 and the phase difference with theta here, and the path followed by the particles under the action of these two resultant simple harmonic motions is called the Lissajous figure. Here Lissajous figure is nothing that is the resultant path followed by two SHM by the action of simple harmonic motion to that of particle. That resultant path is known as the Lissajous figure. Here we derive the Lissajous figure 1:2 means two simple harmonic motions which are perpendicular with each other having different amplitudes and the frequencies ratios as 1:2, and we get that Lissajous figure by using graphical method. So the shape of that Lissajous figure depend upon various points as the amplitude, and phase difference, amplitude, time period, and the phase difference are the key points on which the shape of the Lissajous figure depends. Now we have various conditions according to the phase difference between the two SHM. Accordingly, we derive what be the Lissajous figure by graphical method. Case number 1, when phase difference between two SHM, two simple harmonic motion are zero phase difference, then what should be the Lissajous figure here? We take a circle, that circle having radius b and center at O2, that for particle let P2. Again another circle which having the radius a, center at O1 of particle P1, and we divide that circle into 4 equal parts. So the 4 equal parts x o x dash, y o y dash. Here the position of that particle vibrating which is perpendicular to that of x direction along y. Here the starting point and the vibration, just like anticlockwise sense, the positions as 0, 1, 2, 3, again here 4, 5, 6, 7, here again 8. Next, since the ratios of frequencies are 1:2, so that circle is divided into 8 equal parts. Now we join it as x o x dash, y o y dash, 8 different parts. This position of this point are same, that point are in the same line alignment, Here the starting point of that particle from that point. Here the particle P2 is vibrating, that the position 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now we join their projections as these two are perpendicular with each other. First 0 line, it's 0, then it's 0, that point for 0, then for 1, then for 1, then for 2, that line also for 2, then for 3, that line for 3, then for 4, here that line also for 4, and here 4 line is this, so that is for 4 also. For 5, that line for 5, that one, that be the line for 5, then 6 line here, that point for 6, then 7, that line for 7, and here for 7, the point is 7, then 8, that line for 8, and here for 8. Now I join these points 1, 2, 3 to 4, 7, 8, 5. So the figure is just like the shape of 8. So that type of figure also we have when we derive in case of analytical method. Here that is the Lissajous figure when the phase difference between the SHM are 0, that is the edge shaped. Similarly, we draw another Lissajous figure by using the conditions as when the phase difference between the two simple SHM, case number 2, when phase difference between two simple harmonic motions is quarter of the smaller time period. The phase difference between two SHM is quarter of that of smaller time period. Then what be the Lissajous figure? Same thing. Here we take a circle having radius B, center at O2 for particle P2. Then same thing also here for particle P1, center O1 having radius 1. We divide it 4 parts, x dash, y dash are the particle vibrating from that position 0, 1, 2, 3, again 4, 5, 6, 7, here 8, that is do 8 similar parts x dash, y dash, the position of the particles they are the same way. The position started here as the phase difference between the SHM is quarter of that of smaller time period. So the starting point is here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I join these points as 0, here 0, then 1, here 1, then 2, that line for 2, then 3 line this, that line also for 3, then 4, that line for 4, that line also for 4, 5, that line for 5, this line also for 5, then 6, here that line for 6, then 7, here the line 7, here the line 7, that point, then 8, that line with the 8, that line with the 8, that line also 8. Now join the points. So it is just like that parabola which is symmetric about that axis. Here the distance is 2a from this to this and 2b from that to that. The rectangle having sides 2a and 2b, here that parabola is inscribed. That figure also we get in case of analytical method. when the phase difference of 2 SSM is quarter of that of smaller time period. Next case number 3. When phase difference between two simple SSM, between two simple harmonic motions is 3/4 of the smaller time period, Again, take that circle O2 and it is divided into 8 similar parts, x dash, y dash. Next circle center at O1 for particle P1 of radius A. It is divided into 4 parts as the ratios of frequencies as 1:2, x dash, y dash. So the position of that particle here from that point, so 0, 1, 2, 3, 4, 5, 6, 7, 8. Since it is 3/4 of that of smaller time period, so the position at that case started here 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I join the points as 0 line here, that for 0 line, for 1 line, that for 1 line, 2 line, that for 2 line. Next 3, that point with the same here for 3. Next 4 line, here 4 line, that point also 4. 5 line, here the points are for 5 line. Then 6th line, it is for 6th line. Then for 7, it's for 7 line. Then for 8, here 8, here 8, that for 8. Now join the points. The points are joining just 8 shaped. That be the Lissajous figure when the phase difference between 2 SSM is 3/4 of that smaller time period. That is the Lissajous figure, as that figure also derived in case of analytical method for 1:2 frequency. Next case number 4. When this is the phase difference between the SSM is half of that of smaller time period. This is 1/2, that is the half of that of smaller time period. Next we calculating 3/4. when phase difference, here the position is 0, here the position is, that is the half phase difference between two SHM is 3/4 of the smaller time period. Let me draw that Lissajous figure in similar pattern. Dividing it into 8 similar parts. YO, Y dash, it into 4 different parts. The position started here 0, 1, 2, 3, 4, again 5, 6, 7, here 8. Next, are that of case are 3/4. So the position started same thing 0, 1, 2, 3, 4, 5, 6, 7, 8. Now joining the lines, this is 0 line, 0 line, 1 line, that for 1 line, 2 line, this for 2 line, next 3 line, that for 3 line, 4th line, this figure also for 4th line, 5th line, it is for 5th line, 6th line, here the line be the 6th line, next 7th line, 7th line, that point also for 7th line, next 8th line, here the point also for 8th line. Now joining these points, we have a parabola just like this. This is the shape of a parabola when the phase difference between the SHM is 3/4 of that of smaller period. So with the help of this video lecture, we understand the Lissajous figure 1:2 by graphical method as the superposition of two perpendicular simple harmonic motions of different amplitudes and the periods in the ratio of 1:2. When the phase difference between the SHM is 0, that be the Lissajous figure. When the phase difference between the SHM is quarter of that of smaller time, that will be the Lissajous figure. When the phase difference between the two SHM is half of the smaller time period, that will be the Lissajous figure. And again, if the phase difference between the SHM is 3/4 of the smaller time period, that will be the Lissajous figure. These are the Lissajous figure of 1:2 by graphical method. So with this useful and informative notes, let me wind up this session. Thank you.